Hey guys, welcome back to another video. Today I have this really fancy curved OLED TV to take apart. You can see that this TV screen is extremely thin. It's only about 1/4 of an inch. And since this is an OLED screen, it has no backlight. An OLED screen differs in its technology from a traditional LCD because the individual subpixels are made out of very small LEDs, and those LEDs on their own are very bright, so it doesn't need a backlight. Because of this, it is able to reproduce colors very accurately. Because there is no backlight, there is not constant light coming through the black pixels. So when this TV shows black, it is completely black because all the pixels are individually turned off and there is no light going through those pixels. Here's the back of the TV. You can see the cover that is covering up our power supply and motherboards. Here's our main tag. You can see this TV was manufactured in June of 2015. Back in 2015, when this TV was manufactured, OLED was a very new technology, so I'm sure this TV was very expensive. Over here is our connectors where you would connect the TV to your video source. Alright, so let's get this cover off and see what we got underneath. First, we have to take this aluminum stand off, and then we can take off the back cover. Alright, so here's what we got underneath. You can see we have this ginormous power supply board over here. Down here is our row and column driver board, and over here is our motherboard. Alright, let's take off the power supply board and take a closer look at its components. Okay, so here's our giant power supply board. Over here we can see these giant inductors that actually go through the circuit board. You can see those ginormous high power traces on the back here. This is all mains power stuff. These 4 components here on these heat sinks are bridge rectifiers, which turn AC into DC. Over here we have a relay which is mounted on its own little stand-up board. We have some capacitors. We have 4 transformers here. Under the rest of these heat sinks we're going to have MOSFETs and transistors. Here we have 3 more transformers. We have more heat sinks here, which we do have MOSFETs under, you can see them. And we have some power supply management chips here. You can see these traces are absolutely huge. You can see how big they are compared to my thumb. You can see these traces here have solder on them, which makes them able to carry more current. You can see they have actually labeled the primary and secondary side of the power supply, which is cool. All of this side here would be your primary side. This is where your mains power comes in. It goes through some filtering and stuff. And then this is a secondary side. You can see it's connected to the primary with transformers and opto-isolators. This is another secondary side. You can tell because it's got transformers and an opto-isolator. This is also part of the secondary side. You can see these transformers and this opto-isolator here. We have some filter caps and then our transistors under here. This connector here is supplying our low voltage output to the rest of the TV, and same thing with this connector here. We're going to have various voltages. You can actually see the table here of the voltages and their current ratings, and same thing here. Alright, next let's take off our main motherboard. Over here we have the different connectors. You can see this is what was powering the board, the connector that came off of the power supply board. These wires here go to our speakers. This ribbon wire here takes our video data that was processed by our main SoC and delivers it to our X and Y driver board. These wires over here go to the buttons on the back and the remote control receiver. Okay, here's our main motherboard here. This giant chunk of ceramic here is meant to act like a heat sink for our main SoC, or system on a chip, which is like our main CPU for the TV pretty much. You can see it does have a thermal pad on it, which would be making contact to this piece of aluminum here that is mounted on the back cover. This main SoC here is responsible for decoding video that is coming in through these connectors. You can see all the traces are directly routing them to here. You can see the video memory around the SoC. Once each frame is processed with our SoC here, it would be saved to this video memory before it is refetched by the SoC and then sent out of the SoC to this connector. This is a smart TV, so there is going to be some kind of CPU core in this SoC. Actually, I was wrong. This is not a video memory chip here. This is a NAND flash chip, which is responsible for storing the firmware and the software that the TV uses. These are the chips that are the video memory. You can see that we have this piece on top of these two chips, and we have like nothing on the back. It is interesting to see the traces and where they go. Okay, let's take off our row and column driver board. You can see the wire coming from the power supply board, supplying it with power, and our main ribbon cable goes down here and connects to the board. These connectors here coming off of our row and column driver board go to the actual LCD panel. Alright, here's our row and column driver board. We've got this aluminum heatsink on it with some heat pads on it. Over here we have this nice chip over here with its own video memory. So this board is responsible for taking in our video data from the main motherboard and addressing it to the different rows and columns of pixels. So we have this main chip here, which is going to be doing most of those calculations and routing our video data out to these connectors here. The memory surrounding this chip here, these three chips, is probably some sort of frame buffer, or it's similar to the main SoC where it calculates information and saves that information to the memory before it needs to be refetched and sent out to these connectors that go to the display. This chip here also does calculations for the colors and the intensity of each subpixel in order to reproduce a certain picture. And again, this processed data is going to be information that drives the LCD by its different rows and columns of pixels. On the back cover where our row and column driver board are, you can see we did have this pretty big piece of aluminum to help dissipate more heat. Kind of surprised there wasn't any like thermal pads connecting the two. Alright, here is our speaker modules. We have our left and right speakers here. These just come off. They're not held on by any screws since they were being held down by the cover screws. You can see we have these connectors here. These speakers do have those square magnets to try to save space. We have a nice port here. Here's our driver here. And these modules actually do have a tweeter, which is nice because most of these TVs don't have tweeters on them. So this TV probably had somewhat decent sound quality. These speakers here are good for being reused in various projects where you need sound. Over here we have our power button assembly. Here's our main power button, and then this can be moved up and down, kind of like a joystick. There's not too much interesting here. We have 3 wires connecting it to the main motherboard. Here's the front piece here, which detects the infrared light from your remote control, and this does have a light up logo on it. When you plug it in and turn it on, it does light up. You can see the circuit board in there. just connected on with this connector. So lastly, over here we have some other kind of module here. I believe this is for Bluetooth and Wi-Fi, because this is a smart TV and it connects to the Wi-Fi. Here we can see some shielding, LG Electronics, Wi-Fi Bluetooth combo module. Now that we have our circuit boards removed, you can see the metal structure behind it. Over here and right here, we can see the cast aluminum pieces where our stand connected. This piece here is made out of thick die-cast aluminum because it needs to bear the weight of the TV. Alright, next I'm going to try to take apart the screen a little bit more. It looks like that this metal rim here will come off and allow me to separate the different layers of the screen. Alright guys, so I'm slowly peeling apart this display. You can see we do have this thick aluminum piece on the back, which is painted black. Then we have the inner structure of the display, which is made out of aluminum, that all these screw posts are connected to. Then we have the actual LCD panel here. Alright guys, so here's our actual screen. You can see it's very thin, only about maybe a 1/16 of an inch thick. It's just this big wobbly panel. On the back here you can see the circuit boards that take in the different voltages for driving the rows and columns of pixels. And you can see it distributes this data through this circuit board and out to these different ribbon cables here. You can see that I've pulled up this board from its adhesive, and you can see these little chiplets here on every single one of these ribbon cables. These little chips are responsible for turning on and off the small transistors that are actually inside the panel that supply power to each subpixel. And here is the back piece, which is basically this big aluminum frame that's different aluminum pieces sandwiched together with like adhesive foam. And there's our tag here for the actual display, 55-inch. Alright guys, so I've actually noticed that we have these little ribbon wire things here with little tiny chips on them, similar to what we have on the vertical side of the screen. This is rather interesting because these do serve some kind of purpose to the screen, but it's not connected to a circuit board. Probably like driving the horizontal columns of pixels. This is quite interesting because I've never seen anything like this before. Alright guys, so I've noticed something really cool when I was taking the screen apart. We have these adhesive strips here that hold on the screen, but we also have another method of securing the screen, and that is actually using magnets. All of this here is actually one big thin magnet piece, and on the back of the screen here we have a thin sheet of steel. So the screen is actually being held to the frame by magnets. You can see it just sticks on, and you can also see that screws stick to it. This is a really neat design by the engineers at LG because this makes the screen much more easy to replace, and it is not being held down with like massive loads of adhesive. So it would be pretty easy to replace the screen because it's just being held on by magnets and these little adhesive strips, which is a really cool design that hasn't really been done before in other TVs. Honestly, it makes me wonder what engineer came up with and proposed this idea, because this is really unconventional. Alright guys, so that's about it for this video. I really hope you guys learned a little something here, and thanks for watching.